Chapter 1: Getting Started with MIT App Inventor. What is coding? What exactly is coding? Coding is what makes it possible for us to create computer software, apps, and websites. Your browser, your OS, the apps on your phone, Facebook, they are all made with code. Learning coding empowers you to do many things you wouldn't otherwise be able to do. These things include handcrafting your own websites, becoming a career coder, or even starting a technology business. Most importantly, you'll be able to understand the technology shaping your world. There are thousands of coding languages in existence today. Coding languages aren't like our languages. There are no vocabularies or alphabets. They're more like codes, special commands, abbreviations, and ways of arranging text. All software is written in some kind of coding language. And every coding language is unique, designed with a certain operating system, platform, coding style, and intended use in mind. Some of the coding languages are JavaScript, Python, PHP, Java, Ruby, etc. What kinds of programming jobs are out there? Software application developer. Software developers are responsible for creating and enhancing applications for cell phones, tablets, and other mobile devices. Web developer. How a website looks and functions is the direct result of a web developer's work. Web developers listen well to their clients' needs and solve problems to give them the best website possible for their business. Computer systems engineer. Computer systems engineers are responsible for identifying solutions to complex applications problems, systems administration issues, or network concerns. What is MIT App Inventor? MIT App Inventor is a cloud-based tool, which means you can build apps right in our browser. Before you begin, make sure you have access to the following things: a computer with internet access and Chrome or any other modern browser. A Gmail account. This is how you will log in to App Inventor. Starting MIT App Inventor with email ID other than Gmail account. 1. Open the browser and type Create Account in MIT App Inventor. 2. Click on the website MIT App Inventor Login. 3. Click on Create an Account. 4. Type email ID and click on Send Code or Link option. 5. The code is sent to your email ID. Enter the code and click on Submit. 6. It will ask you to set a password. Enter your password and click on Submit. 7. Now, log in with email ID and password. 8. Click and I accept the terms of service. MIT App Inventor website opens with Welcome dialog box. Click in Do Not Show Again checkbox and click on Continue. Starting MIT App Inventor with Gmail account. 1. Open Google Chrome or any other browser. 2. Type http://ai2.appinventor.mit.edu in the address bar. The website opens. Click on Create Apps button. If you have created an account and you're not currently signed into your Google account, you will be asked to sign in. Enter the email ID. If you have multiple email IDs, select the desired email ID to sign in. App Inventor saves all of your projects to their server under the name on your Google account, so any progress you make now will be saved for the next time you open the program. 8. Click and I accept the terms of service. MIT App Inventor website opens with Welcome dialog box. Click in Do Not Show Again checkbox and click on Continue. 9. Click on Start Blank Project. After signing in, if this is the first time you are using App Inventor, you will see a blank project page. 1. Click Start New Project on the left side at the top of the page. 2. Enter the project name as one word with no spaces in the dialog box that appears and then click OK. Designer View. The browser will open the web page for your project in Designer Editor. The designer editor is the place where you select components for your app and design the user interface, that is, screen layout of the app when you open it. Designer editor. The designer editor has several sections you want to become familiar with: the palette, viewer, components, media and properties sections as shown in the image below. 1. Designer button. Click on Designer tab to go to Designer Editor. 2. Palette. The palette contains all the elements that make the app perform any number of tasks. All these elements are listed under various groups like user interface, layout, media, drawing and animation, sensors, connectivity, etc. 3. Viewer. Drag components from the palette to the viewer to see what your app will look like. It also contains non-visible components that are placed at the bottom of the viewer. Example: speech recognizer, text-to-speech, etc. 4. Components media. It lists all the components added from the palette, and we can upload media files used in the app. 5. Properties. Select a component in the component list to change its properties, color, size, behavior here. Let's explore various options available in the palette. User interface. The user interface element holds several components that are essential to build your app. Note that all the components in this group have visual aspects, such as text color and font size, that you can change either in the designer editor while creating the app or as the app is running using commands available in the blocks editor. Button. This component adds a button that can be clicked with the user's finger. You can customize its appearance in a number of ways. Checkbox. The checkbox raises an event when the user clicks it. You can use both the designer editor and the blocks editor to customize its appearance. Image. This component adds images to your app. Label. A label displays a piece of text that can give further organization to your app. List picker. This button displays a list of text elements for the user to choose from. List view. This component places a list of text elements on your screen for display. It will not work on screens that are scrollable. Notifier. This component displays a notification. You can customize how it appears and what kind of information it will save through the Android log entries. Text box. As its name implies, this is a box to add text. You can customize whether the text box has multiple lines and whether it is restricted to numbers, among other specific features. Web viewer. This creates a component for viewing web pages inside the app without sending the user to an external browser. Layout. The formatting elements in which to place components that should be displayed are listed under this tab. Horizontal arrangement. Components are displayed from left to right. Horizontal scroll arrangement. Components are scrollable. Table arrangement. Components placed are displayed in tabular form. Vertical arrangement. Components are displayed one below another. Vertical scroll arrangement. Components are vertically scrollable. Media. Many Android applications today make extensive use of various forms of media. CBM App Inventor gives you many choices for including videos, images, or sounds. These components enable you to create an app that can access the device's video recorder or camera. This is also where you add your own images, a fairly frequent occurrence in most apps. Image picker. This tool makes it possible for users to import an image from their device. When this button is selected, the device's gallery appears and an image can be selected. Player. This is a multimedia component that plays audio and video and also controls the phone's vibration. Sound. This component plays sound files and vibrates for a specified number of milliseconds if specified in the blocks editor. CBM App Inventor recommends this for shorter sound files, such as sound effects. Sound recorder. This component records the audio. Speech recognizer. This component is useful for giving the user the capability to speak into the device's microphone and have it recognized by the app, commonly known as speech-to-text. Text-to-speech. With this component, your app can speak to a user by turning text into spoken audio. Translator. This component uses a translation service to translate words and phrases among different languages. Be sure your test device is online while trying any app that is using this component. Drawing and animation. App Inventor has several components that enable the user to draw or interact with animation inside the app. We use these in one of our sample apps later in the text. The components include the following. Ball. The ball is a round sprite, an interactive image that can react to touches, drags, and interactions with other such sprites. Canvas. The canvas is a touch-sensitive area where you can add sprites. Image sprite. Just like a ball, this is a sprite that can be touched and dragged and can also interact with other sprites. Sensors. The sensors are components that interact with some of the hardware features on an Android device. For example, these are useful while building an app that interacts with a user's location, device movement, or other hardware through near-field communication. Accelerometer sensor. The accelerometer is a hardware built into the device that can measure movement. Storage. The following components interact with data and storage, so you can create an app that saves information on the device and interacts with any collected data. TinyDB. This component stores data for an app. Connectivity. This component can launch a variety of different activities, including performing a web search, starting the camera, and opening another app that was built with App Inventor. To Bluetooth components also enable an app to connect with Bluetooth devices. Blocks Editor. The block screen has code blocks, which help to code the functionality of the app. Control. If-else statements, while loops, etc. Logic. True, false, equal, not equal, etc. Math operators. Text. Blocks that deal with text. Lists. Blocks for handling lists. Colors. Blocks to handle colors, like choosing a color, make the color, and split colors. Variables. Initialize variables, setting variables values, get variables values, etc. Bluetooth client. This provides the names and addresses of paired Bluetooth devices and indicates whether Bluetooth is enabled. Procedures. Procedures are like functions. A procedure is a sequence of code blocks with a given name. Later, you can call that sequence of blocks instead of creating the same long sequence. Inside each group, you have blocks that you can drag to the viewer. In the viewer, you drag the blocks and join them in a specific way to make something happen. In the backpack, you save code blocks to use later. You move blocks to the dustbin to delete them. Specifying sizes of components. When you create a visible component in the designer, you are typically given the opportunity to specify its height and width. There are 3 choices. 1. Automatic. Size is chosen by the system. 2. Fill parent. Size is chosen to fill the space available. 3. Size specified in pixels or percent. Note: since not all Android devices have the same screen size, it's good to avoid specifying sizes numerically as pixels if possible. Connecting your device. As you build this app, you can keep track of its development by seeing how it looks in real time. The recommended method for doing this is to install the MIT AI2 companion app on an Android device. You can find it in the Google Play Store by performing a search for MIT AI2 companion. To connect your app to your device in App Inventor on your computer, click the AI companion link from the Connect tab. You can then type in a 6-digit code or scan the QR code with your device using the App Inventor app. Doing either brings up a live view of your app. As you add elements to it with the MIT App Inventor software, those changes will reflect in real time on your device. Testing on an emulator. If you do not have an Android phone or tablet, you can still build apps with App Inventor. App Inventor provides an Android emulator, which works just like an Android but appears on your computer screen. Steps to download the emulator. Step 1. Open the website cbmsmartseries.in and click on Resources. Step 2. Click on App Inventor Simulator. Step 3. Click on first option, Android App Simulator Setup. The setup file will be downloaded. Now, open the download folder and install the application. Step 4. After the download and installation is done, follow the steps given below to test the app. 1. Open your project in MIT App Inventor. Click on Build Android App.apk. Once APK file is prepared, a dialog box will open. Click Download.apk now option to download the app in your computer. 2. Launch the AI Starter app on your computer and keep it running in the background. 3. To test the app in the emulator, click Install APK option on the toolbar, select and open the APK file, check whether the app is working properly. If not, review the code and debug the errors. Saving your project. Take a backup of your App Inventor projects by saving them to your computer's hard drive. To save a copy of an individual App Inventor project, open the project and click Projects, Export Selected Project.aia to My Computer. Uploading project from device. To import an individual App Inventor project, open the project and click Projects, Import Project.aia from My Computer.